Now we're going to get to our examples and try to make sure that we can find what they ask us to find using some of those things that we just discussed. Okay? So I hope you're ready. This one is two parts. They're going to first ask us to find tangent of some angle. They're not telling us what it is yet. We'll get to that eventually. But they're giving us cotangent. Doesn't get any easier than that. As long as you know what tangent and cotangent's relationship is. And hopefully you know, because we just went over it in depth, that those are reciprocal functions. And therefore, since they gave us that this is 4/1, we know that this is going to be 1/4. Done. That is it. It's that easy. And of course, they're not all going to be this easy, but let's take a look at example 2. And if you want to pause it right here and give this one a try on your own, please do. Because this time they're asking for secant and they gave us cosine of that angle theta. So since we are given the ratio for cosine, we know that secant, reading it right to left, is the reciprocal function of cosine, not sine, even though it starts with an S. So be careful with that. So I know all I got to do is flip-flop that ratio. We call it the reciprocal in math. Still going to be negative. The positive and negative is not going to change. But then I have the square root of 20/2, which is really nice. That's why they left the root in the denominator in the original problem. But don't forget, they always prefer us to simplify before we give our final answer. And if you remember how to deal with square roots, you can break them up and find out what their factors are of the inside in hopes that you can actually take the square root of one of them. And I do know the square root of 4, so that will give me a -2 on the outside of our root, but I do not know how to take the square root of 5, so I'll leave it. And remember, friends, the only time that you can ever cancel is when you are multiplying. Make a note of that if you don't already have that knowledge. Only time that you can simplify is when you are multiplying. Not adding, subtracting, dividing, don't do it. Okay? And since these are multiplying, we then know when we do the division of 2/2, we get 1, so we can simplify. So my final answer for this would be negative the square root of 5 over 1, but not necessary. Okay? So that's example 1, pretty straightforward, just making sure that you understand and know the definitions. Example 2 here asks us to determine the signs of the trig functions of this angle in standard position with the given measures. Now, all I'm going to do is sine of that angle, cosine, and tangent. I'm not going to do the other ones because I know cosecant, secant, and cotangent, respectively, from top to bottom, will be the same because they're just the reciprocal, right? So all I really need to know is where is 54 degrees located, in what quadrant. This is utilizing the all students take calculus or text in class. And because we are at 54 degrees, we know that we are going to be in quadrant 1, somewhere about here. And therefore, we know that all of these are going to be positive, including the reciprocal of each sine, cosine, and tangent. Okay? So do me a favor, go ahead and pause it right here and go ahead and try parts B and C and then come back real quick and I'll finish it with you. All right, hopefully you're able to get from the 260 degrees where that is located. I know that it is definitely more than 180, but not quite to the next 90 quadrantal angle, 270. We're just shy of that here. So that would put me all students take. So the only things that would be positive would be tangent and its reciprocal function, cotangent. All the others, sine, cosecant, cosine, and secant, they would all be negative. Okay, hopefully you're able to get that. And then negative 60, again, be careful. Remember, we always start with reference to our x-axis and in the positive direction from the origin. So we're always starting this direction, and if we go up, that is positive. If we go down, remember that's negative. And so therefore this would be negative 90 rather than 270 because we're going in the negative direction. And so I would be in this quadrant somewhere. Therefore, I know the acronym All Students Take Calculus represents cosine and its reciprocal function, which is secant, would be the positive cases. So for this one, only cosine of our angle and secant of our angle would be positive. All others negative. And for part B, we said it was tangent of that angle and cotangent. And again, I could write 260. It's just quicker to write theta. All right. So this is something that we're going to utilize a lot. It's very important. So be careful with it. Make sure that you memorize not only what that represents, but then how to use it. All right. Example 3 here. A little bit different than the previous example. They want us to still identify the quadrant or possible quadrants of our angle that would satisfy the given conditions. So now we're being asked, what quadrants could we be in? Still going to be looking at this. And so since tangent is greater than 0, that means positive. Where is tangent positive? Well, remember everything's positive in quadrant 1. And then students take calculus. So here or here. Not there, not there. That's not where it's positive. So we already got it narrowed down to 2 out of our 4 answers. So since they possibly might want us to just be in 1 quadrant rather than 2, they also gave us another thing to utilize, and that is cosecant being less than 0, which means negative. And if anything is negative, that means by far we definitely are not in quadrant 1 because everything, all are positive there. And so even though cosecant is the reciprocal of sine, we are good because sine is only positive there. So it is good that cosecant is negative and tangent is positive in quadrant 3. So that would be our answer to part A. So now that I've done one, go ahead and pause it here and give it a try on part B and come back and we'll see if you got the right answer. All right, hopefully you gave it a try. Again, simply utilizing our all students text in class moniker to help us remember what trig functions are positive where. And remember, it only talks about the big 3, so hopefully you know the relationship for the reciprocal functions is identical as far as the signs go. The ratio will be the only thing that's flipped. So since sine is greater than 0, meaning we're dealing with positive, we know that quadrants 3 and 4 are out, 1 and 2 are possibilities. We could be here, we could be there. But then this one was a little bit tricky because they told us cosecant is also greater than 0, which means positive. And cosecant is simply the reciprocal function of sine, not cosine. Don't get that mixed up. It happens often. So therefore, we know that it's the same 2 quadrants. So that's why it said possible quadrants. This one would be 1 or 2 for our angle. So there could be more than one possibility for some of these as we progress. Hopefully you got that answer. If not, keep practicing. It'll get easier as we go because this will not go away. As I mentioned, chapter 1, super important. All right, moving on to the next one here. As I mentioned, a little less in the notes, more in the examples, and really making sure that we can use this stuff the correct way. So this one says, you know what? I'm going to give you an angle in quadrant 3. So right then and there, I'm going to stop and I'm going to draw this out. I'm going to draw so that I have a visual of what I'm dealing with, quadrant 3. I don't even need all the other quadrants. But then they tell me some angle is in that quadrant, right? So when I go to draw that, I'm going to draw it no specific way necessarily, or maybe I wait and I see what other information they gave me before I draw it. Because I then see that they say tangent of the angle theta that they gave us in quadrant 3 is equal to 8/5. So what are they giving us right there? Because there's a different way that they could actually give this question. But hopefully you recognize that is giving us what? Remember, tangent of any angle is always the y over the x. And since they told us it's equal to 8/5, they are literally giving us an ordered pair, a point as 5, 8, or x, y. Now, notice it appears to be positive. And here's a big mistake that students will make. Yes, it looks like the 8/5 is a positive 8 over a positive 5, but what if I had made each of those negative? What do you always want to do with your final product, your answer? You give it in the simplest form. And therefore, that's why they got rid of the negatives. So technically, to get in quadrant 3, it would have been the point -5, -8. So when I go to draw this, I'm actually going to go -5, -8 to get to that point. You need to recognize that. Then I can draw my radius to that to get my angle, theta they're calling it, in this right triangle that we have then drawn to get to that endpoint. But again, the key is that you know it's -5 and -8. Now, what if you forget? What if you accidentally just put the 5 and the 8? Again, hopefully you put them in the proper places with the x and the y and not reversed, which also happens. You're okay. There's another way. Because remember, they did ask us on this to find what? The 5 other trig functions. So that means we actually need to find, they already gave us this. And so I should be able to tell them immediately, without having done any of that drawing, any of the thought, I know immediately, since this is 8/5, that's 5/8, because they're reciprocal in nature, by definition. So in reality, I only need to find these two. If I can find those two, then I also know that cosecant and secant are the reciprocal of those. But remember, sine is always the y over the r, and cosine is the x over the r. And I have x and y. They gave us that by telling us tangent. But we need the r. And so what are we going to do in order to find that? Hopefully you said Pythagorean theorem. And we'll take the two legs squared, add them together, and set it equal to our hypotenuse, we are calling r squared. And so multiplying that out, we get 25 plus 64. Adding that together, the 20 and the 60 is 80. 5 and 4 is 9, so we get 89. And in order to find what that actually would be as a value, we would unfortunately have to take the square root of 89. Now I know the square root of 81 is 9, so this is going to be more than 9. But how much more, I don't know. So that's called an irrational number because we can't write it as a nice ratio. It's a long decimal that never ends, never repeats. So we are simply going to leave it as the square root of 89. Now don't forget, it should have been plus and minus, but we're talking about a radius, so always going to take the positive case. And unless that you can make this look simpler by breaking it down into its product of factors and then taking the square root of any of those factors that you know, then you're just going to leave it. So the good news is we don't have to do anything with the 89. The bad news is we know already it's going to be in the denominator. We're going to have to simplify that. So I know the y and I know the x, and now we also have our r. So we should be able to finish this, but as I mentioned, what if you forgot this negative for the x and the y? How else can you get by knowing whether things are going to be positive or negative? Well, remember the previous examples that we just did. We knew, since we're in quadrant 3, that the only things that should be positive were the tangent and cotangent, which means I already know that every other one of my trig functions are going to be negative. All we have to do is find the ratios. So in order to finish this, we'll go ahead and do the y over r for sine, which we knew the y was 8 and the r was the square root of 89. And before I even rationalize that denominator to get rid of the root in the denominator, I will flip it and do the cosecant and get my final answer there. I'll do the same thing with cosine, which remember was x over r, and the x value was -5, and the r was 89. So again, before I actually simplify that and finish it by getting rid of the root in the denominator, I will flip that as well. So either one you're going to have to do. Order doesn't matter, but I'll start with the cosine since I'm already on that color. Remember, the only way that I can change that ratio's appearance, without changing its value is multiplying by this fancy 1. And since it didn't have a square term underneath the square root with that 89 when we tried to break it down, then we're going to make it have one by multiplying by itself. And so that would give me a final answer of -5 times the square root of 89 over 89. And that's what I would put there as the simplified form. And you can probably guess what would happen with the other one, sine. It would be -8 times the square root of 89 over 89 in place of that. Okay? So in reality, we only really had to find 2 in order to find the reciprocal functions, and this one they gave us, so we just wrote down the reciprocal function. So again, remember the big 3, sine, cosine, tangent. If you can get those, then the other ones kind of just fall in place. All right, next example here. They want us to find just 2 trig functions. In this problem here, they are asking for cosine and tangent. Again, you can ask for all the other ones or specific ones like this. Just a mixture of types of problems. So again, be very careful, but pay attention to details. Very, very important in this class. Find that cosine for theta and tangent for theta was to figure out what quadrant we're in. And then, as I mentioned a couple videos ago, drawing these things out really, really does help. Okay, so 2 more pieces of information that they gave us was that sine is equal to that ratio and cosine has to be greater than 0. So that's helping us with some of the parts that we were dealing with earlier and figuring out what quadrant in order to draw this. Now remember, with sine, they're also telling us what 2 values out of the 3 in my triangle that I'm going to end up drawing. Y and R. And so since cosine has to be positive, I know it's going to be anything to the right here because that's where x is positive. So we know right off the bat that we're not in quadrants 2 or 3, but either 1 or 4. And I also know I'm not in 1 because they gave us one of our trig functions and it happened to be negative. So cannot be in quadrant 1 either. So I've got it narrowed down to quadrant 4. So I'm going to go ahead and draw this very quickly. And then we're going to see if we can pencil in some of these things. So again, you're drawing 4 theta. Doesn't really matter if you don't care that it's to scale, but to get there, I know that I have been given the y and the r value. And I also know that in order to get to this point, I would have to drop this perpendicular straight down to the x-axis always. And I then need to know that this is some positive value, this is some negative value, and this is always positive. And by the way, I should already know whether these 2 points that they asked us to find for cosine of the angle and tangent of the angle, what are those ratios going to come out? Well, because we know we got it narrowed down to quadrant 4, we knew that this one should be positive and this one should be negative. All we got to finish by doing is finding the ratios. So one more time, they gave me sine, which I know is the y over the r. So my y value would be the square root of 2, and the r would be 3. And as long as we know 2 out of our 3 parts of our triangle, we can find the third by using what? And because it's a right triangle, has to be a right triangle, then we can use, hopefully you said, the Pythagorean theorem. Now be careful. That's why I'm doing another similar example like the one that we just did. When you do the Pythagorean theorem, the unknown part, in this case the x that we're trying to find, is not always what the Pythagorean theorem is going to be equal to. Because remember, the hypotenuse is the most important piece. That's the one that's always by itself because it's the biggest. So we're going to have an x squared plus ry squared equals the r squared. And therefore I know that the 3 would be by itself and the negative root 2 over there. Now there's also another way you can do it. You can use the Pythagorean identity that we just dealt with the sine squared plus cosine squared equals 1 and go that way as well. It's totally up to you. I'm going to do it this way because I know a negative squared is positive, and when I square a square root, it becomes a 2. 3 squared is 9. Pretty simple. All I got to do is subtract the 2 over so that I can take the square root. And once I do that, I will then have my x value. Now this one could be positive or negative, but because we are going to the right, we know that it was positive in this case, square root of 7. And now that I have all 3 values, I don't care what trig function they ask me, I should be able to answer. Now, since they did say cosine, I know cosine is the x over r and tangent y over x. And so to answer my final answer, I take the x, which is square root of 7, over the r, which was 3 for cosine. And then for tangent, it was the y value, which, careful, was the negative that we already had there, square root of 2, over the x, which is the square root of 7. So of course, with that one, they are going to want a little bit extra. So we're going to have to go ahead and multiply by that fancy 1 of square root of 7 to top and bottom, because that is just 1. And anything times 1 is itself. So we'll get a final answer of negative. When you're multiplying like roots, you can do just that and multiply and get that like root over square root of 7. Square root of 7 is the square root of 49, or 7. And so that would be our answer for the second part, tangent of that angle. So please be careful with your signs, pay attention to details, many different ways to do that, but kind of gave you the 2 different options of using the Pythagorean theorem or the Pythagorean identity I told you to memorize. So here is our 6th and final. Again, I've tried to harp to you all. This is a very, very important section, part of the class that if you understand chapters 1, 2, and then 3, you're going to be set to do really, really well for the rest of the class. So I'm trying to overemphasize some of these examples with you. Go ahead and pause it right here and see if you can work this one out, very similar to the previous. All right, hopefully you gave yourself some time to work this out on your own. This time they want us to find sine and cosine, which is pretty nice. And they also made it a little bit simpler and just simply telling us that our angle is in quadrant 2. We didn't have to think about it a whole lot. So when we go to draw this, my X, my Y-axis, and then I will draw my angle theta. Now, of course, with that angle, I'm going to drop that straight down to the X-axis so that I have my right triangle. And because they gave me cotangent, that I know is the reciprocal of tangent. And since tangent is y over x, I know cotangent is going to be x over y. I already know that this is going to be a negative direction, this is going to be a positive direction, and our r is always positive. So I also know that the x value that they gave me is going to be what is negative, even though they threw it out in front. The y value is 24, and I can actually look at this and tell you, even though a lot of you, if you actually did pause it and go try this on your own, you use the Pythagorean identity or you use the Pythagorean theorem. Not me, because I recognize that this is a Pythagorean triple that I had written down for you all a couple sections ago. This is actually a 7, 24, 25. If you ever get a nice number like that, you know it is a Pythagorean triple. If it still has the root we call an irrational number, then it's not nice and it's not worth memorizing. So because of that, I now know and have all three sides, so therefore they can ask me any of the 6 trig functions they want to know. And I should say 5 because they already gave me 1. I really wish they asked me for tangent, because then we could just do the reciprocal and be done, right? But sine and cosine, we needed the, for sine, y over r. And for cosine, the x over r. And that would be wrong. That would be a mistake that a lot of people would make, because they would leave off the negative. So whether you figure it out by the direction for those, or you figure it out because we know we're in quadrant 2 and you write this down. I knew sine was going to be positive and cosine negative. However you do it, don't lose your sign. No pun intended. So that is it, my friends. Keep practicing, keep memorizing as much as you possibly can, because it will help you immensely in the future. Until next time, Alan, signing off.